So, good morning, good afternoon to all of you to this fourth webinar in our new series of webinars in ETSAP. We have two presentations today, one by Alexander and one by James, roughly half an hour for each. So we'll try to have 20 minutes presentation plus 10 minutes questions. Please use your chat function if you want to submit questions to the speakers. And the presentations will be recorded and will be uploaded to the YouTube channel that we have for ETSAP. So Alex will start with developing and using times models with Git, GitHub and VEDA. So Alex, you can share your screen.
Thank you, George. And good morning, everyone. Let me share my screen. I hope you can see it. So this will be a walkthrough developing and using times models with Git, GitHub, and VEDA. There will be a limited number of slides, and I will be mostly showing actions on either on the GitHub platform or on my own local computer. First of all, I would like to let you know that in order to repeat the steps that I will be doing, you will have to have a GitHub account. One can get one by registering here. I also have Git version control software installed on my computer, and I'm using an interface for Git called TotalS Git that integrates into Windows context menus. In principle, there are many different GUIs out there, but I prefer using TotalS Git. Let us start. First of all, I will fork an existing times model repository. At the moment, there are not that many times model available on GitHub, but there is model demo in the Canors organization. So to fork this repo to my own account, I press on this green button. Actually, not really. I press on the button in the right top corner, and I choose an organization to which I want to fork it. I fork it to Mirai EPMG, an organization that we use in UCC to do our times model development. And now it has been forked. So you can see it's now under Mirai EPMG. And it's still, GitHub indicates that it was forked from Canors organization. Let me now get it onto my computer. There are different ways of getting a model from GitHub onto your computer, but I will use clone. First of all, I will copy this URL, and then on my own computer, I will use context menus and TotalS Git to execute cloning. I'll choose clone, and then TotalS Git will by default suggest a folder name that is similar to the repository name. Press OK. The model is being cloned now. Depending on the model size, the initial cloning can take some time. This model is not that big, so it finished quite fast. Now you can see that the folder that was created by TotalS Git has icons next to different files, and they indicate whether if the tick marks are green, this means that the files don't have any changes in them that are not committed. Before making any changes to this model, let's look at its version history. TotalS Git has a very nice way of showing version history that is organized into a log, which shows the development tree with the most recent version on top, and then shows a brief description of the change that was introduced compared to the previous version, who introduced it, time that the change was introduced, and also an email address of the author. Moreover, it also shows the files that were modified in a specific version. Let's make some changes to this model. As you can see at the moment, the repository has 3 branches. Master branch, which is red colored, and it means that it's the branch which is present on my local computer and it's active. And then there are 2 other branches on the remote, origin master and origin head. Head is a convention which just points to the most recent version. So in order to make changes, I will create a new branch. In general, it's a very good idea to use branches for introducing changes and not to commit to master branch directly, because normally you want to keep master branch stable and available for your team to use. I'll give it a name. And I will instruct Tortoise Git to switch to that new branch right away. As you can see, our log changes, and now make changes branch was created, and it's in red, while the local master branch became green, indicating that the make changes branch is active. Let's introduce a simple change. For example, let's edit system settings file. Let's, for example, change the discount rate. I'd like to change it to 4%. Save the file. Now, as you can see, the icon next to system settings file became red, and it indicates that there are some changes which haven't been committed yet. So let's go ahead and commit those changes. Basically, committing changes means storing a version of the file in the repository so that one can come back to that version later on. Let's write a message. Change. By convention, normally one writes messages in an active form. So basically, in this case, one would like to indicate what this particular commit does. So it changes discount rate to 4%. Normally, users tend to write what they have done instead, but by convention and good practice is to write it in the active form and describe what the commit does. As you can see in here in the lower part of the window, the file that is being modified is shown. Let's commit it. Now the file is green again. If we now check the log, we can see that the make changes branch is one commit ahead of the master branch, and we can see that the repository on the GitHub is not aware about those changes yet. This is because one has to push the changes to the remote repository before they become available there. So let's do just that. Let's push our changes to GitHub. As you can see on the right part of the screen, the GitHub right away updates the information on the platform and alerts me that make changes branch has been pushed recently. Let's see how this is reflected in the log. Yeah, so now we have our master branch on the remote is also one commit behind the make changes branch. Now let's look into how we can integrate this change into the master branch. GitHub, after noticing that some changes were done to a branch, GitHub right away suggests to compare the changes and create a pull request. Let's do that. As you can see, a form opens with most options preset. In this case, let's make sure that that we're integrating changes to the right version of the master branch. By default, it includes the original repository in the settings here. So the one which belongs to Canors. Now this form also allows you to describe the changes in greater detail. One can also assign reviewers to solicit feedback from, as well as assignees in case an issue needs to be taken care of. One can also label the pull request in order to categorize it depending on what it represents. For example, it can be fixing a bug, or it can be introducing new development. So let's create this pull request. And as you can see, the pull request has been created, and it's pull request number 1. GitHub tells us that this branch has no conflicts with the base branch, and we can safely merge it. So let's do that. Now the change has been included in the master branch. GitHub also suggests us to delete the original make changes branch. In general, it's a good idea to destroy or delete branches once they've been integrated to the master branch. This is just to avoid any confusion in the future when making further changes. Let's take a look at our repository on my repository on my local computer. If I check the log, I still don't see any changes to the master branch. That's because I need to update my local information about the changes in the remote repository. To do that, I can fetch. What fetch does, it downloads all the changes from the remote repository to all the branches, but doesn't make any changes locally. So if I check the log function again, I will see that the remote branches have been updated, but my local master branch is still the same as before. To update my local branch, I will first switch to it. And then I will execute the pull command. And the pull command will basically check the remote repository for changes and integrate those changes to my local branch with the corresponding name. So as you can see now, the master branch on my local computer has been updated. Yes. So this is briefly about how to make changes, how to get a model, and how to introduce changes, and how to share it with GitHub. Let's now take a look at some useful functionality available on GitHub that can support model development. One functionality that I especially like is the issue tracker, which allows users and model developers to report issues with the model, have discussion on the platform, and then make the changes and keep track of it. One needs to activate issue tracker for a repository. So it's available under settings menu, and one has to tick issues here. Then a tab called issues appears, and one can start registering issues or reporting issues. I just make a sample issue. I'll just put some random text here, which is basically in the title. One should write the problem or the suggestion, and then have a detailed description. Yeah. And then one can submit the issue. And then issue is given a number, and this numbering goes hand in hand with pull requests. So they're numbered one after another. And then this issue functionality allows to assign colleagues that should take care of it or should take part in the discussion. One can label issues, for example, whether it's a bug or some help is wanted or it's some kind of enhancement. And then one can also tag team members and have a discussion about the issue. So for example, I'll just include James into the discussion about this issue. And then once a commit is made that addresses this issue and the pull request is issued, it's possible to reference this issue by number. And then once that commit is integrated into the master branch, then the issue will be closed automatically. So that's on issues. One other functionality that I think is also very useful, it's code owners. Code owners in GitHub allow to designate specific persons that are assigned, that should review changes to specific files. Let's see how to do this. In order to use code owners functionality, we need to add a file to the repository that is called code owners. And this is specific GitHub functionality, so it's good to keep it in the .github folder. And then in here, let's say I will let's say James should be the one who needs to approve changes to system settings file. So I include this information in here. And in here, one can use different wildcards to, for example, apply this rule to all XLSX files or specific files or subfolders. So I will just commit this new file. In order to make this rule applicable automatically, one should also adjust some settings in the repository. So I will go to settings, and I will protect master branch. So I will make it not possible to integrate any changes to the master branch without a pull request. And I will take a mark here to require review from code owners. And maybe I will also apply this rule to administrators as well. So now this rule is created, and any further changes to the syssettings file will have to be reviewed by James. So this is more or less it on the GitHub functionality. I can see that I'm don't have that much time left, so I'll just have the last slide, giving some thoughts about using VEDA and the version control files and the version controlled model. So in here, basically, one can use the version control files directly. One can use VEDA to sync files directly from the version controlled model folder. And this is very straightforward. It's like we've always done. And then VEDA is also able to trace the input data back to version controlled files and open them. However, when working with multiple branches, it introduces some challenges, because then one will change the content of the folder, and VEDA will have to resync again. And then it's also quite difficult to have several branches active at the same time. For example, if one is contributing to multiple branches or developing several sectors. And then also files which have field tables will be shown as modified upon sync. So those are not the changes that user makes, but the changes that VEDA does. So in order to address those issues, there's a possibility to export individual branches to VEDA models folder using hooks. Hooks are special files that are run after certain events. So for example, after a commit is made, or after a pull is made, or after a merge happens. So it allows one to easily work with multiple branches, because it puts them separately into different subfolders in the VEDA models folder. And then it also gives the user complete control over modifications that happen to the file. However, it also introduces some challenges, which are it's a bit less straightforward approach, because one is not syncing version control files. So one has to remember to make changes only in the version control files, or if one makes changes into the exported branch files, then one has to transfer them manually and commit them in the version controlled folder. And then another limitation is that VEDA cannot trace the input data back to version controlled files, because often it also won't know where they are located, or which branch it should access. George, I think I think I'll stop here and then see if anyone has any questions.
Okay, thanks, Alexander. I don't see any questions in the chat, but if anybody has any questions, please, you can switch on your mic and camera and ask Alex directly.
There is a raised hand from Bruno.
Yeah. So Bruno, please.
Yeah. Thanks for the interesting presentation. A quick question, you're tracking the Excel file. One of the great features of the Git is the diff view, which allows you to see the difference between two files when you're writing code. And then when you're tracking the Excel files, the diff view, because it's kind of machine, can you see anything that is human readable? Because the alternative would be to track the DD files, and then you would be able to see, have you tried that? You would then be able to see the diff, and then you would actually see the number that changed, the original number, the new number, or the discount rate. Whereas now you wouldn't see that unless you open the two files and put them side by side. And for spreadsheets, it's quite hard to see when you have lots of numbers in a spreadsheet. I mean, we've tried that on the DD file with answer. It doesn't work so well, but with the imp files, which is a text-based kind of translation of the Excel file into an intermediate step before the DD file, we found that the diff view works quite well on that. I'm just wondering if you've tried it on DD files with VEDA.
Yeah, so it's basically two questions, right? So the first question regarding the Excel files, in principle, so what I use quite often is the Excel spreadsheet compare tool. and it's possible to automate it to show the differences between two files. Let's see whether it works now. So for example, on the system settings file, let's see, it's loading. So it will basically feed two versions of the file automatically to spreadsheet compare tool, the old version and the new version, and then it will show the changes, or it will tell what changes have been made. So this works quite nicely as long as one modifies cells like that, or if one, for example, inserts ranges. If one drags ranges around a spreadsheet, then there'll be a lot of changes shown here. This is basically then cell ranges are the values from them are deleted and then assigned to new cells. So that's a lot of changes. And then regarding the, oh yeah, and then maybe one more comment about this. So unfortunately, with Excel files, it's not really possible to do a three-way comparison, which is extremely useful with the text files. So where you can compare two model versions or two file versions with a common ancestor. So with Excel files, one has to do kind of two-way comparisons to find out what has changed. And then regarding DD files, so I've used an approach which is also available in the ETSAP and the ETSAP organization, the times demo model. So basically, where one exports model as DD files, and then one can run it without VEDA, and one can also make some changes to those files without VEDA. And we have an example under we have a times decay example under Energy Modeling Club repository, which is similar to that.
Great, thanks, Alex. There's another question in the chat. If you could read it and answer, please.
Okay, let me just find it. Somehow Zoom is hiding the chat from me.
Okay, I can read it for you. So if a major change is performed on the model, change of time slice structure, adding a set or etc., do you recommend to have that stored in the same tree, or to simply create a new one from scratch and track the versions of this new model separately from the original one?
I think it all depends on the extent of changes and how those changes are made. So for example, with respect to, so in UCC, in EPMG, we are at the moment, we're developing Times Island model. And in there, at the moment, we combine sector-specific models with the whole energy system model, and a whole energy system model for a single region with a whole energy system model for on the county level. So it all depends on how many files are common and how, for example, time slices are handled. For example, if one constraints, or if one includes all the time slice information in a single file, then it's easy to do the development in a single repository, because all the other files will be same or with minor differences. So the short answer, it depends how you handle the changes.
Good, thanks. I don't see any other questions on the chat, and I don't see any raised hands, so I think we can move on. Great, thanks, Alex. So
I'll stop sharing my screen.
Yeah, great on timing. So it's exactly 30 minutes. So we can move on to James then. James will talk on data management and version control in collaborative multi-regional times models. So James, you can start sharing your screen. Great, thanks.
Thanks, George. So I presume you can see my screen.
Yes.
So it's the slides you see. Okay. So just a quick rundown of what I'm planning to go through today. The same as Olex, I don't have slides. I have one slide, this one, and the rest is just going to be talking through some data and some methods that we use in developing multi-regional models. So either the global models like ETSAP TM or Times Geo, or multi-regional national models like the Times Ireland model that that Olex was introducing. So I'm going to give a little introduction to Tableau, which is I guess a commercial grade database visualization package, data management package. I'm going to do an example with viewing, sorting, aggregating the IEA extended energy balances from the raw CSV file that you get from the IEA. Create a database out of the energy balance, and then aggregate the energy balance into the regions that we might want in Tableau. And then I'm going to do a quick example of how we can integrate data tables that are exported from Tableau to update the new 30 region ETSAP TM templates. And I know in the description of this webinar, I said I'd make the regions larger, but just because it'd be useful for me to do it, I'm just going to make them smaller, so bring it to 15 regions rather than 30 regions. How we do that is going to quickly update the system settings file for the regional definitions, and also update the base year templates. So I'll just do an example of the electricity sector, and then Olex has already talked these things through to commit these changes to a GitHub repository where ETSAP TM is, and also go to push, and then you can see the changes that I've made. Or sorry, if you had access to the secure GitHub repository, you could see the changes made in GitHub. And also, if we have time, then I'll talk through some interesting things if you're looking at the power plant level, how to aggregate individual plants if you have longitude and latitude data to get them into regional definitions that are useful for you for your model. So I'll stop with that, and I'll start showing some data first. So when we get the IEA energy balance from the IEA, it looks something like the following. So you generally get this big giant zip file from the IEA. It's something like 21 gigabytes of data, and I wouldn't try doing anything with that in Excel given the size of it. So the first thing I do is I read in this this large CSV file with the full IEA energy balance into a data cleaning tool called Tableau Prep, which is part of the Tableau software. So it reads in this 21 gigabyte CSV file from the IEA. You can do some very simple cleaning of the data if there's any misspellings, or if you want to assign different fields to, so if you want to let the database know that your country field is a region or a geography, you can do all that here. So basically, you can do your cleaning up, and then you can convert the CSV file into various different data formats, so that Tableau can read this very efficiently and quickly. I converted into a file format called a Tableau data extract. So it's a hyper file. It's basically the same format as, or when you read it, it's basically the same format as a CSV file. So you have the same headers and the same fields that you get from the IEA. So the measure is basically the unit. So you have kilotons of oil equivalent or petajoules. You have the country code, so world or all the different countries in the database. You have the product, so that's basically commodities in times lexicon, and then you have the flow, which is different energy consumption, production bins, basically the IEA energy balance. You have the years and you have the values. So all the values are in the single one column. So I'll leave that there. And then when I'm trying to visualize this or do anything with it, I just open up that same extract file in Tableau and you read it in like this. So when you literally just open the extract file that you would have created in Tableau Prep, you can see the data as it's read in from Tableau. So it's the same column headers. You've got your measures, so your units, the country code, the country description, the products, the product description, the flow description, etc. as you see in the IEA energy balance. And then as you do things with this data in Tableau, the new fields and new fields and new data points appear here in the data set. But what's more useful is to view the data visually within Tableau. So starting off with the IEA energy balance, this is all the countries that are available within the IEA energy balance. There's some countries in Africa missing. There's some countries in developing Asia, but by and large, there's 147 countries. So most of them are available. So the full resolution is something like this. You've got 147 countries. So first off, what we're trying to do is to figure out how can we don't want to have a 147 region model. We want to aggregate some of our regions together. So it's very easy to create these aggregated regions in Tableau. If I wanted to create a North America region, I can literally just select North Canada and and the United States. I can create a group, and that group should hopefully have appeared in this edit group. So you can, just by visually selecting regions, you can, and holding down control, you can select all the regions within the IEA energy balance, right click on them, and create a group. Okay, so I'm not going to do this now because we don't have the time to do it manually. So I've created two different sets of groups. So the old ETSAP TM regions. So the old ETSAP TM regions. So the 15 region model for ETSAP TM, and the newer regional definition that we've been working on the last 2 years for the 31 region ETSAP TM model. So all I've done is gone around and selected all these different regions and created this set of groups and this set of groups. So if you're looking in this data in Tableau, all it is I've named each of these groups with the names that I want to appear in the times templates. So within the China group, you've got the data that's within the IEA energy balance. So the native regions within the IEA energy balance, and the same thing with Africa. You've got all the different countries in Africa. Okay, so that's basically how you would create a group in Tableau. So you can then use those groups that you've visually created to start looking at your data. So I want to see what data, or what are the products and flows coming from the IEA energy balance. And I want to sort this so that I can use it within my and within my base year templates for ETSAP TM. So I'm just dragging over these fields that are within the energy balance, organizing them by the groups of regions that we've just created, and I just want to drag in the values that we get from the energy balance. So what we've done then is created our IEA energy balance by the region definitions that we want to use. We've got 15 regions. It's really easy to make some other regional definition. I want 31 regions. I just drag that in. It takes a minute to compute, and I get my 15 region. You could have 147 regions, whatever disaggregation you want. So I've done this already for the 31 region definition and the 15 region definition for the IE energy balance. The other thing I should say, sorry, is that because we have the IE energy balance has two different units, it has terajoules and kilotons of oil equivalent, and you also have every year from 1960 to 2019, you also need to create a filter that you can change this table between whatever base year you want. So you could, this we have this set up at the moment to be filtered to create an energy balance for 2015, but you could as easily just go to the newest year and create an energy balance, well, if the data was available, an energy balance for 2018. Let's go back to, well, let's see if 2017 is available. Okay, so you could have a base year energy balance for 2017 if you wanted. So that's important. Sometimes Tableau, I find it's a database software aggregator and visualization software. So sometimes it does things that you don't expect. It's aggregating, averaging data points within a database, and you need to be very clear about what you're visualizing and what you're plotting. So that you need to have the right filters on to make sure that you're getting the data points you're expecting to. So then, if we want to bring this into our times base year templates, we can either, if you have a particularly strong computer and you can copy this all into your RAM, you can just copy and paste this. So copy the data or copy it in Excel format. It's probably safer just to export it cross tab to Excel. So this will take a minute or two to create this file in an Excel file. So I have these already produced. I've put them here. So we have these two, a 31 region and a 15 region energy balance coming from the IEA energy balance. So they should, I'll just open this up so that you can see it. So we basically get our IEA energy balance in terajoules for each of the regions that we created in Tableau. So we have these 15 regions, and then we have this other spare one. The IEA has their own aggregations in their energy balances with groups of clusters of African countries, clusters of North American countries. So you need to make sure to filter these out when you're bringing these into your times base year templates. So that's what the energy balance looks like. I think it's about 7,346 rows long, and yeah, it's as you see it. So this the same one for the 31 region. Okay, so I'll go. So we have these two Excel files that we've aggregated the IEA energy balance data into the regions that we want. So I should just be very clear that these columns are the regions that we've defined. So this is Africa East, Africa North, Africa West, Africa South, Australia, New Zealand, Argentina, etc. across, and then you have the data for each commodity or product within the energy balance, and then for each sector. So agriculture sector, has these 70 different commodities, and this is what's these are the numbers within the energy balance for those different commodities in that sector. So I'll leave those open. So if I then want to view the TM base year templates, so I've created the same that Olex was showing earlier on. I've a few repositories in here. So I just created this one this morning, 7 hours ago. So as Olex was showing, we have our main branch and our this ETSAP webinar branch, and I've already synced and pushed, or sorry, committed and pushed the existing base year templates to GitHub online. And so just so that nobody's freaking out, this is a private, secure GitHub repository. So I think I have about 5 minutes left. Okay, so if I open up the correct, the GitHub, sorry, the ETSAP TM model folders within the GitHub on my local machine, there's 2 places that I need to change our regional definitions. So one of them is in the system settings file, and the other one is in the base year templates. So, and I should say that myself and Maurizio Gargiulo from E4ISMA have developed these specifically so that they can be quickly changed. The regional definitions can be very easily changed. So right now, I'm in the system settings of the new ETSAP TM templates, and we have the 31 region specification. So let's change this to 15 regions. So I have my 15 region IEA energy balance, and I'm just going to take the old ETSAP TM code names and put them into my system settings. This one that's orange is the one that we exported from Tableau earlier on in the webinar, so it just takes a few minutes to export it. I'm just going to close that. So go to system settings, and we want to change these to the new 15 regions, and we just get rid of the other 16 regions from the 31 definition, and we just save that. So we've got these, our old 15 regions from ETSAP TM defined in our system settings, and we save that. And straight away, I hope I have this opened in the right place. Nope, wrong folder, sorry. So straight away, the system settings is showing a change here, that GitHub has marked this, that there's been an update, and the icon is kind of clear to see that this has changed. The other folder, or the other file that we want to change then is to update the electricity base year template as an example. Hopefully it doesn't crash. Okay, so the way these templates have been constructed is it's different to the old ETSAP TM templates. They are, all regions are in one template, and we have different BY templates for each sector. You can see it in VEDA 2 here that we have these electricity sector, industry sector, residential, commercial, and agriculture sector, and the transport sector in just single BY templates for each sector, and then all regions are in those sector BY templates. So I need to change a few things in here to go from 31 regions to 15 regions. So the first thing is we have defined our regions in this cover sheet, if I can find where they are. Here they are. So I want to change we have 31 regions defined in this version, but I want to go from 31 to 15. So I just take my 15 region definition here, And I go back and I paste it into our electricity BY template here. So we've got new 15 regions and we just get rid of the old ones. And I should save that. And OLEX would be telling me that I shouldn't be saving multiple things and making one commit, but given time constraints, I'm just doing this all in one go. So the other thing then, we have defined the energy balances. So this is the energy balance within the electricity base, your template from the 15 region, or sorry, the 31 region. So we've got all the regions across the top, again, Africa East going over to Saudi Arabia, Turkey, Russia, etc. So we can take, again, our 15 region code names from our file that we exported from Tableau. We can go back to our BY template, get rid of the other regions. Can do the same here, just make sure that all the filters are removed as you're doing it. Okay, so we can paste in our 15 region energy balance. Nearly there. Sorry, I should have done this a bit more efficiently, but anyway. Okay, so we have our 15 region energy balance, 7,346 lines long, and we bring that back into our BY template. Get rid of the old regions. And with any luck, everything else updates. So you can see possibly some of these numbers might be a little bit wrong with, I need to double check some if statements we have in here, but basically the rest of the model just automatically updates from looking up the sector the region definitions that we have in the cover sheet, and then the commodity codes. We have a commodity code dictionary that links the IEA code names to what we're calling them in times. And so you get this updated energy balance for electricity sector, updated distribution losses for each of the regions that we have, updated total electricity production by CHP and auto production, etc. And then we just save that. Those numbers look a bit funny actually, but we can hopefully fix that in the future. And we go back to our file here. You can see GitHub is, our Git desktop is showing us that the system settings has changed, and the base year template for electricity sector has changed. And we just go to OLEX is using Tortoise Git. I'm just using GitHub, Git desktop, I think it's called. Maybe it doesn't matter. So change regions from 31 to 15 in electricity sector. Electricity, I can't spell, and commit that to the branch that we created, and we push that to the origin. Hopefully there's nothing conflicting. And then if I refresh this, then the version changes that I've made, moving the model definition from 31 to 15 is available then on GitHub online to anybody else who has access to that repository. So George, I better stop there. We've about 5 minutes left. I won't bother doing the hydro stuff I was going to do.
Okay, thanks, James. Questions? Please either raise your hand or submit something through the chat. I don't see anything there, James. So Bruno says, do the hydro. So go ahead. Since we don't have any questions or anything else, so
okay.
Yeah, go ahead.
So hydro. So similarly to aggregating the IEA energy balance regionally, there's a few different databases that are now available for every single power, or maybe about 85 to 90% of the global power plants. So you get their longitude, latitude, their fuel type, their capacity, their turnkey date, etc. So in our times geo model that we're developing as part of the Chimera project that I'm working on, we want to have higher kind of temporal and spatial resolution. So we've built an hourly global dispatch model basically in times. And some of the things that we had to try and figure out is, well, how do you aggregate all the longitude and latitude data into the regions within your model? So if I want to do this, you can have all your longitude and latitude data, and then for each of these points, you've got the data associated with that hydro dam, the capacity of that dam, and then using NASA reanalysis data, you can look up the hydro flows and the river flows at that location to get kind of estimates of capacity factors on a seasonal basis. So you can highlight all the dams in China, for example, and do the same thing that I did earlier on. You can right-click, make a group. I just want to create a country region for China, for example. I'm not going to bother doing that, but I've done this already. So you just create all these regions within whichever definitions you want. So we've created a 258 region power sector disaggregation. But you can aggregate it to however many you want. I did an example here earlier on just by highlighting and selecting, and you can have all of Europe and all the other hydro dams separately. So it looks like about a minute left. So by using this, then you can cross-reference the NASA reanalysis data that I was saying to get the hydropower capacity factors for each of those longitude and latitudes. You can cross-reference the location of the hydro dam with spatial or with physical data, let's say, so the capacity factor or the flow of the river nearby. You can look at one, or you can look at a few, and then we can obviously take these capacity factors into times in the same way that we did with the other with the IEA energy balance. So we aggregate them into regions. We have the time, whether the year, you can get rid of quarter, the month, and the day, and then we can get each of the aggregated flows of hydropower. So the gigawatt hours or the terajoules of hydropower in each region in 2015 in this example. So we can export this out and use these as capacity factor constraints then within our times model. I'll stop there, George.
Okay, thanks, James.
Okay.
So any comments or questions so far? Question on data management using Power Query. Could you check on the chat there? And what was the name of the data set for hydroflows?
So it's a combination of the World Resource Institute database gives you the capacities and the locations, and then we have a script that uses MIRA, so NASA reanalysis data, so climate downscaling to get the run-of-river flows at each of the longitude and latitudes that come from the World Resources Institute database. So it's using climate reanalysis data to get the hydro data capacity factors and flows. So one of the renewable ninjas, which is run out by Ian Steffel in Imperial College London, is one of the places you can get that kind of data. George, like Olex, I can't find the
chat box.
questions.
Okay, so so a question is: have you any experience to manage data using Power Query?
No, I don't.
Okay. Access to the Tableau tool?
It's free for academic use. It's about €1,500 a seat for commercial use. They don't. They're much more focused on financial and business interfaces, but I think they're increasingly aware of scientific and research opportunities, so they're open to collaborating with universities, but we wouldn't be their typical user base.
Great. So I think that's all at the moment. I don't see anything else. Any other questions? Great. You did great on timing as well. So I think we can close this webinar at this point. We're planning to have, like I said, webinars either on a monthly or a bi-monthly basis, depending on the subject. So if you have any topics that you would be interested in, please get in touch with me, and we can arrange for a webinar on this. And the announcements will be circulated by email. We're using this long email list. So if you want to be added to this, or somebody else wants to be added to this emailing list, please go to the ETSAP website and register for our newsletter. So thanks again to Olex and James for the presentations, and I hope you'll join us for one of the other webinars we will organize. Thanks a lot. Okay.
Cheers, George. Thank you.
Bye. Thanks.